What if I told you a mysterious object from beyond our solar system has just shattered into 16 fragments, and astronomers have no idea whether it's a comet or something far stranger? Stick around, because what happens next will blow your mind. Imagine this. A Harvard astrophysicist has just released an analysis that sent a shiver through the entire astronomy world. According to his calculations, 3I Atlas may have broken apart into at least 16 pieces, a cosmic rupture so violent that the traces of its destruction are still unraveling across the void. And this isn't rumor or guesswork. This is data-driven, telescope-captured, scientifically grounded reality. If you're captivated by the mystery of 3I Atlas and want more mind-bending cosmic stories, smash that like button and let the universe know you're watching. Every click helps keep the search for the unknown alive. Picture an interstellar traveler racing toward our sun, already wrapped in mystery, already defying expectations. And then, somewhere near its closest passage, something inside it gives way. The object tears itself apart, transforming from a single solid wanderer into a swarm of fragments, each one spraying material into space, like embers drifting from a dying star. And yet, the deeper you look, the stranger it becomes. The mass loss wasn't gentle. It didn't drift away like a typical comet, quietly melting under solar heat. No, the material was streaming off at rates so extreme, so explosive, that Loeb's equations pointed to an event far more dramatic than standard cometary physics can comfortably allow. According to his models, only one scenario fits the energy demands and the observed outflow: a catastrophic breakup, a moment when the internal structure of 3I Atlas failed completely, splitting it into a constellation of fragments. Even more extraordinary is what this implies. If those fragments are real, and every line of evidence suggests they are, then we are witnessing something almost unheard of: the disintegration of an interstellar object in real time inside our own solar system. Each fragment becomes its own engine of activity, shedding ice and dust, expanding the total surface area until the combined outflow finally matches the mass loss astronomers detected. A single nucleus couldn't do it. A dozen or more could. And in that realization lies the first major turning point in the mystery of 3I Atlas. Because once you accept that it's shattered, you're forced to ask the next question, the one that turns an already extraordinary event into a scientific cliffhanger. What exactly caused 3I Atlas to tear itself apart? Was it natural physics pushed to the breaking point? Or was this the first sign of something far more unexpected? That answer lies ahead. But the story of 3I Atlas doesn't begin with its explosion. It begins months earlier with an observation so strange, so completely out of step with what astronomers expected, that it set the stage for everything that followed. When 3I Atlas was first detected by the Atlas Survey System in Chile, it wasn't just another icy wanderer drifting in from the dark. It was immediately flagged as extraordinary. Only the third confirmed interstellar visitor humanity had ever seen: a cosmic outsider, a messenger from beyond the sun's domain. But what truly stunned astronomers came later, when the James Webb Space Telescope turned its infrared gaze toward it. Webb's instruments captured something impossible to ignore: a massive carbon dioxide halo, a coma, stretching farther than the distance between Earth and the Moon. A shimmering, ghost-like sphere wrapping 3I Atlas in gases no one fully understood. And buried inside that glow were clues, chemical fingerprints that didn't match the ice and dust recipe of typical comets. asterisk. The iron to nickel ratios were skewed. Asterisk. Certain molecules were off. Asterisk. And the spectral data hinted at something that simply didn't align with the cosmic tourists we're used to seeing drift through our skies. Then came the anomaly that changed everything. As 3I Atlas approached the sun, it didn't behave like a passive passenger drifting along its gravitational path. It accelerated not because of momentum, not because of gravity. Something else was pushing it, nudging it, urging it forward with a force that standard physics couldn't fully explain. This wasn't the gentle outgassing astronomers expect from a comet warming in sunlight. This was stronger, sharper, and persistent, a force increasing as it neared perihelion, as if the object were responding to the sun in some unusual way. And if that wasn't enough to raise eyebrows, 3I Atlas began to change color. Faint at first, then undeniable. It grew bluer, a phenomenon comets almost never display. Light reflecting off unusual compounds, metallic signatures, or the product of a transformation triggered by something deeper within the object. One clue after another began stacking up, forming a pattern no one could fully decode. Something was happening inside 3I Atlas. Something building. Something waiting toward a moment that would eventually tear it apart. And the deeper astronomers looked, the stranger the story became. Whatever 3I Atlas was, it wasn't behaving like anything we had ever seen before. By the time 3I Atlas drew closer to the sun, the data coming in no longer whispered unusual, it shouted. Astronomers began witnessing a surge, a dramatic, almost violent escalation in the amount of material the object was shedding. What had started as a steady, manageable release of gas and dust suddenly transformed into a runaway eruption. The mass loss rate multiplied thousands of times over in just a few short weeks. It wasn't subtle. It wasn't gradual. It was explosive. Imagine an object drifting through space, losing a few hundred kilograms of material each second, and then suddenly shifting into a state where it was ejecting millions of kilograms per second, blasting matter outward like a star, shedding its outer layers. No natural comet should jump from calm to chaos at that scale, not without something snapping inside it. When Abelob analyzed the numbers and ran them through the physics, the results defied every expectation. At perihelion, the sunlight hitting 3I Atlas delivered only a certain amount of energy, nowhere near enough to vaporize the oceans of material we were observing. For the mass loss rate to make sense, 3I Atlas would need a surface area far larger than the tiny nucleus Hubble had imaged months earlier. Not just slightly larger, an order of magnitude larger, it would require an immense sphere spanning more than a dozen kilometers across. But that was impossible. Hubble had seen a nucleus only a couple of kilometers wide. There was no record of it growing, no sign of expansion, no mysterious inflation, unless it wasn't one object anymore. And that's where the breakthrough came. If 3I Atlas had shattered into many pieces, 16, maybe more, everything suddenly snapped into place. A breadcrumb trail of physics aligned. Each fragment added surface area. Each fragment contributed to the furious outgassing. Together, they produced the enormous mass loss rates astronomers were measuring. Not a single comet, but a swarm. Not a lone traveler, but a broken constellation of icy shards racing together through space. But there was a problem, a complication that made the scientific community hesitate. If this were a typical fragmentation event, the debris cloud should look messy, chaotic, diffuse. The pieces should drift apart in random directions with no structure, no coherence, no pattern. Instead, something unexpected was forming, something that did not look like chaos at all. The next set of observations revealed jets, tails, anti-tails, structures too organized, too precise, too sculpted to match the story of a simple natural breakup. 3I Atlas had shattered, yes. But what came next suggested that this was only the beginning of a much deeper mystery. When new images of the object arrived from British astronomers, the entire narrative pivoted. What they captured did not resemble the aftermath of a comet tearing itself apart in a chaotic blaze of dust and rubble. It looked organized, structured, intentionally shaped. Michael Butner and Frank Nebling of the British Astronomical Association pointed their equipment toward the cosmic visitor just days after it swung behind the Sunday. What they recorded didn't merely surprise the community, it shook it. Instead of a drifting haze of scattered debris, 3I Atlas displayed a phenomenon so rare, so geometrically distinct, that it demanded a second look, an anti-tail, a stream of material pointing straight toward the Sunday. Comet tails are pushed away from the sun by solar radiation. They should never lean into it. But this one did, and not delicately. It was sharp, bright, unmistakable, a nearly 1,000,000-kilometer spear of material stretching sunward, defying the rule book of cometary behavior. Then came the real shock. A second jet, then a third, then others. Elongated columns of gas and dust extended in the opposite direction, forming a structure nearly 3 million kilometers long. These weren't wisps, nor ragged filaments drifting apart after an explosion. They looked collocated, focused, directional, aligned. Even more astonishing, additional astrophotographers around the world confirmed the pattern. Observers like M. Yeager, G. Raymond, and E. Prosper Bibby recorded the same thing. Multiple jets, many forming anti-tails, each exhibiting symmetry and geometry that felt far too precise for debris scattering from a shattered nucleus. This wasn't a cloud. It was a pattern with angles, directions, and structure. And that's where the most unsettling question emerged, the one Avi Loeb's calculations had quietly gestured toward from the beginning. If 3I Atlas had truly broken apart, how were its fragments still producing such orderly, synchronized jets? Fragments shouldn't do that. Fragments are unpredictable. Fragments do not cooperate. Yet every model built to explain the behavior collapsed under scrutiny. The required force would need to be enormous. Yet there was no sign of anything capable of generating it. The region looked empty, silent, cold, but somehow exerted a pull that defied logic. The mystery deepened when an observatory in the southern hemisphere detected a faint flicker near the corridor's center. It wasn't bright enough to be a star, nor did it resemble ice or rock. It pulsed once and vanished. Instruments caught a brief spike of radiation, a signature unlike any cataloged source. Loeb urged caution, suggesting that something hidden in that darkness might be interacting with the remnants of 3I Atlas. But whether it was a natural cosmic anomaly or something far stranger remained unknown. All anyone could agree on was this: the fragments were converging with purpose, and whatever they were approaching had begun to reveal itself. By early November, 3I Atlas re-emerged from behind the sun, bringing the clearest and most detailed observations yet. Space and ground-based telescopes captured the fragments shimmering in sunlight, their jets clearly visible, stretching millions of kilometers into space. But what truly stunned astronomers wasn't their size or brightness, it was the organization of the jets themselves. Instead of chaotic plumes scattering randomly after a breakup, the fragments displayed a geometry that seemed intentional. Multiple antitails pointed toward the sun, while collimated jets arched in precise orientations, forming an almost symmetrical pattern across the sky. Some of these structures spanned an area comparable to the apparent diameter of the moon or sun when viewed from Earth. Loeb recalculated again. If the fragments were natural, the energy required to sustain these jets at this scale was staggering. The pieces should have cooled and slowed within days, yet the mass loss remained extreme, ejecting billions of tons of material per month. Something was sustaining them, something far more efficient than solar sublimation. The mystery was now undeniable. The evidence was piling up like a cosmic puzzle. Asterisk fragments moving in coordinated paths, asterisk highly organized jets, mass loss far exceeding expectations, asterisk trajectories that suggested intention. At this point, even the most conservative astronomers were forced to confront the question hanging silently in every observation room. Could 3I Atlas be more than a natural comet? Every calculation, every image, every spike of data now pointed toward a single, unsettling possibility. This was a visitor unlike anything humanity had ever encountered. As comparisons rolled in, the contrast grew sharper. Oumuamua, discovered years earlier, was silent. No tail, no jets, just a fleeting shadow slipping through the solar system. Borisov behaved like a classic comet, shedding material predictably as it neared the sunday. 3I Atlas, however, refused to fit into any known category. It was unmistakably cometary in composition, ice, carbon dioxide, dust, yet its behavior was anything but ordinary. The mass loss rates, the geometric antitails, the accelerating fragments all combined to form a cascade of anomalies no model had anticipated. Then came the moment of pattern recognition, the point where researchers fell silent. Each anomaly could be explained alone, perhaps brushed aside as a natural variation, but together they formed something far more disturbing than coincidence, a chain of interconnected oddities, a sequence of phenomena that collectively suggested 3I Atlas was doing something unprecedented. The world's eyes turned skyward, not only because of what was happening, but when, for the first time in human history, we had the technological capability to study an interstellar object in real time. Space telescopes, Earth-based networks, and even spacecraft orbiting Mars fed a global web of observations that earlier interstellar visitors had never been subjected to. This convergence of technology and timing was breathtakingly rare. 3I Atlas had arrived at the exact moment humanity could truly watch, measure, and model every detail. And as its fragments continued displaying coordinated motion and organized jets, the stakes grew higher. The coming weeks would determine whether we were witnessing a natural comet pushed to the limits of physics or something entirely beyond our understanding. Don't stop here. The universe is full of secrets waiting to be uncovered. Click on the next video and join us as we explore even more astonishing mysteries from the farthest reaches of space.